Let us have a look at a common hose connection system often used on plant and mobile equipment. This is sometimes referred to as 4-bolt flange, with several standards and designs being supplied to the market. For comparison purposes, we've selected a range of 1.5-inch hose tails including Code 61, Code 62, Letourneau Komatsu and Supercat. These hose tails are generally rated between 3,000 and 6,000 psi. Looking at these images, it may be difficult to see the important differences at the flange. This selection of hose tails are both rated at 3,000 psi and consists of Code 61 and Komatsu hose tails. Looking at the Code 61 and Komatsu hose tails, the flanges appear to be nearly identical. The difference here being the O-ring groove in the Code 61 is imperial, while the O-ring groove in the flange for the Komatsu hose tail is metric. So, while there is only a small difference in these flange sizes, the flange clamps and Code 61 and Komatsu are compatible with each other. Looking at the hose tail selection again, the first hose tails are rated at 3,000 psi. The next hose tail is rated at 5,000 psi and is known in the industry as the Letourneau. Looking at the Letourneau hose tail, again it appears that this hose tail is very similar in size to the Code 61 and Komatsu flanges, but in this instance, the head of the Letourneau flange is thicker by approximately 3 millimeters. So, while there is only a small difference in these flange sizes, the flange clamps for Code 61 and Komatsu are not compatible with the Letourneau. Pirtek list within their catalogue the AZLT split clamps, which are to be used in conjunction with the Letourneau flange. Moving on to the last of our selection, both these hose tails are rated at 6,000 psi. These hose tails are known in the industry as Code 62 and Supercat. The flanges appear to be very similar. In fact, the flange diameter and O-ring groove are exactly the same. Generally, all Supercat flanges have a thickness of 14.2 millimeters, whereas the Code 62 flange in this instance is thinner by approximately 1.5 millimeters. So again, while there is only a small difference in these two flange sizes, the flange clamps are not interchangeable. In short, many flanges may look identical, but that is not the case, and mixing components can lead to system failure, severe injury, or even death and destruction of property. 4-bolt split flange assembly. If a split flange is installed incorrectly, the O-ring will fail, resulting in an oil leakage. The correct installation of the flange is as follows. Inspect all components for damage or contamination, particularly at the sealing faces. Install the correct O-ring in the flange groove, ensuring the O-ring is not twisted. Lubricate the bolt threads. Align the flange and the two clamp halves to the port. Install the 4 bolts, hand tightening evenly to seal the O-ring on the port face. Torque the 4 bolts, alternating in a diagonal pattern to about 80 to 85% of the final recommended torque. Finally, torque the 4 bolts, alternating in the same diagonal pattern to the final recommended torque. Looking at the O-rings used in more detail, we have already learnt that some styles of flange utilise imperial O-rings while others utilise metric O-rings. Just by looking at these samples, it's nearly impossible to see which is metric and which is imperial. Pirtek lists within their catalogue the KY series of O-ring, which are metric to suit the Komatsu flanges. The Y series are imperial and suit both Code 61 and Code 62 flanges. All these have a round cross-section manufactured from Buna N and have working temperature range of -34 degrees Celsius and 120 degrees Celsius. The YD series of O-rings are for genuine Caterpillar XT flanges only. These have a D cross-section. Also listed are the OKS series high performance seal. This seal has a specialised rectangular cross-section and can be used to replace the Y-series O-ring for use in arduous areas. These are manufactured from a polyester polyurethane material having a working temperature range of -30 degrees Celsius to 100 degrees Celsius.